Hello, and welcome to Hands-on Arduino. Welcome to Hands-on Arduino Part 6. I call this loads of LEDs because that's what we're going to be looking at. And of course, loads and LEDs. Anyway. Handling lots of LEDs is the topic for this presentation. We're going to talk a little bit about multiplexing and something called Charlieplexing. A little bit different name. But the basic idea is we want to be lighting LEDs. So here's a circuit in which we have a number of LEDs and resistors and connections. So what happens when we apply 5 volts on one end and ground on the other? Well, this is what happens. We apply 5 volts here and ground here. So notice that the current is flowing in the direction that the diode is pointing. These are LEDs, light-emitting diodes. Okay? And so what happens is that current can flow in the direction of those diodes. And notice it doesn't matter if the resistance is here, divided between the two, or on this side. It's going to light with the exact same brightness. So that's good to know. If you want to light an LED, this is an example of how you would do that. So 300 ohms gives a reasonable brightness for LEDs. You can use other values for lighting LEDs, but this is a common one. So notice that I have an LED here, and this one is not lit. Okay? And the reason it's not lit is because the current would be going against the arrow of the LED. Okay? So that's one of the things about an LED as a diode. It allows current to go one way, but not the other way. Okay? So if we now turned it around and reversed the voltage, that is, we put 5 volts over here and ground over here, these guys are going to turn off and this guy will turn on. So that is critical. That's a critical point. So in terms of lighting LEDs, again, here I have 2 LEDs in parallel with one another, 150 ohm resistor on either side. If I put the 5 volts over here and ground over here, this LED lights. If I reverse it, the other LED lights. So this principle that I've shown here is behind something called Charlieplexing. And so basically what you do is you have the different connections to your circuit and you apply either plus 5 volts or ground to either side. Of course, if you apply plus 5 volts to both sides, then you get no current flowing. If you apply ground to both sides, then you get no current flowing. So in those two cases, neither of them are lit. So the only time you get something lit is when one side is 5 volts and the other side is ground, or vice versa. So that's some principles of lighting LEDs. And again, this is the principle that's used in what is called Charlieplexing. So with 2 different connections, in this case, I can light 2 LEDs. If I were to have a third connection, then I can have, 3 pins. I could have either pin be 5 volts or ground, depending on how I configure them. If I put 2 diodes and resistors in between each pair of connections, then that gives me 6 diodes that I can work with. So with 2 pins, I get 2 diodes. With 3 pins, I get 6 diodes. And actually, you get that geometric increase the more pins you add. So the value of Charlieplexing is that with fewer pins, you can light more LEDs. And that's helpful in some settings where you want to use a few number of pins. Now, when we talk about pins, however, are we talking about pins on the Arduino or on another circuit that we would attach to the Arduino to help us do LED lighting? That's an important question. So I'm going to focus primarily on multiplexing as opposed to Charlieplexing. There are many videos out there that talk about Charlieplexing, so I'll let you go check them out yourself. Now, one of the things also about lighting LEDs is this notion of the light does not have to be on constant in order to appear for it to be a steady on light. It can actually flash, and so that's the whole principle of pulse width modulation, for example, is that you can dim or brighten a light depending on the duty cycle of your pulses. But again, the light is flashing. And in that case, the light is actually flashing 500 times per second. And what ends up happening is something called flicker fusion. Flicker fusion. So flicker fusion is basically the frequency at which a flashing light appears to be steady to a human observer. Okay? So that's the concept of flicker fusion. And it's important in all technologies that present moving images. So any kind of movies basically rely upon this idea of flicker fusion. The minimum frequency is 16 hertz. That is, it has to flash at least 16 times a second. Generally, movies will flash 24 times a second. So when you go to the movie theaters, the screen, the image on the screen is actually flashing 24 times a second. The fluorescent lights that we use in our buildings often flash at 120 hertz, and it does that in order to. It turns out that if you reduce it, then you get what is called flicker, and the flicker doesn't fuse as well, and so you get that happening. So if it's flickering, people tend to get fatigued seeing those lights. So it's not a good thing for it to flicker. Now, sometimes people will confuse flicker fusion with persistence of vision. Okay, I'll let you go and look up persistence of vision if you're interested to find out more about that. But flicker fusion is the basic idea behind the fact that when we're going to light LEDs, and in particular, if we think of LEDs in an array. So, for example, on a marquee, you see a bunch of LEDs lit and they're spelling out words or whatever. All of those principles lie in all of those principles lie the idea that flicker fusion. Okay, so in other words, those LEDs in that configuration are probably not all on constantly. They probably are actually flickering, and it's a process of writing to each LED and writing them fast enough so that it looks like it's not flickering. Fast and bright is the basic idea behind a lot of those marquees. So we'll look at some of those here in this presentation. Here's an example of multiplexing. Okay, and that is to light an LED, you need to set the row and ground the column. Okay, so that's basically how this works. You set the row and you ground the column, and grounding the column, by that I mean you hold the other columns high, and this whole process relies upon flicker fusion in terms of how it's presented. So here, what this little video is showing is it's showing the process of lighting each LED one after the other. So the red line means that it has a plus 5 volts. The blue line means that it's ground. And so you can see basically the blue line just goes right across. Okay, the blue line goes right across. It's grounding one after the other. Okay, leaving the others high. So notice that the blue line is moving. Okay, as it goes through this. And then you can see that gradually the horizontal lines also will change, but those change one at a time. So the horizontal lines are all blue and one red. The vertical lines are all red and one blue. And so where those two intersect, the red vertical and the red horizontal and the blue vertical, where those intersect, you get an LED that lights. Okay, and so if you want to light up a particular pattern of LEDs, then you basically will cycle through a pattern of lighting this one, then this one, then this one. So that's what goes on behind this this example. Incidentally, I got this little graphic. It's actually a motion GIF, animated GIF. It's found at this site multiplexing with Arduino and the 74HC595. So that's there's a little instructable there. So you might want to go check that out. And so that's where I pirated these. So now that I've cited it, now it's no longer pirated. It's just referenced. So here we have another example. To light this LED, notice that this guy's blue, this guy's red. Notice all the other guys are blue. All the other horizontal lines are blue. All the other vertical lines are red. And so what's going to happen is to light the diagonal elements, we basically alternate rows and columns so that we only address, in this case, the diagonal elements. Okay, so it maybe is a little confusing, and this thing flashing black is probably not helping. But this is the basic idea. So what you might do is, with this video, move the scrubber a little bit and just point by point, and then see how each LED is lit as it goes through this process. Okay, phew, that was a little hard on the eyes, a little flashing on the eyes. Okay, well, behind multiplexing, it requires that each row and column be addressed. So in a display, every single LED needs to be addressed at some point, and you might write a 0, you might write a 1. And so the process generally goes through and writes a 0 and a 1 to each LED in this way. So in general, an N by M mux, so a mux is a shorthand word for multiplexer, so it's often referred to as a mux. An N by M mux requires N plus M control lines. So however, it's not necessary to have all of these control lines come directly from the Arduino. It's common to use an intermediary chip to help. So this is why I'm saying I'm not going to talk much about Charlieplexing here, because these chips can help us do this. And having a chip to help us, we don't need the complexity of Charlieplexing. We can do direct multiplexing, which is a lot more straightforward, especially when it comes to programming. It can really make a big difference. A lot easier to program if you're just addressing bit by bit. So that definitely makes a difference. So here are some example chips that are used to do this kind of multiplexing. Notice 2 of these are 8-bit shift registers. This one actually has tri-state outputs. So a signal could be positive or negative or neither. It could be floating, okay, disconnected in a sense. So that's what this one does. So notice it has 8 outputs. Okay, it takes a serial input and a clock, and so it communicates serially. Okay, yes, I'm serious. I mean, yes. There's also a serial LED display driver, the MAX 7219 or 7221. It's basically the same chip, except the 7221 makes a lot less electromagnetic interference. It creates less electromagnetic interference. So if you need to use this circuit near a circuit that involves something like audio, the audio you can get what's called crosstalk, where some of the digital signals can basically radiate and be picked up by other wires and anyway create interference. So that's what the 7221 is. Otherwise, the 7219, if you're just doing like a marquee display, that's fine. So it basically has all the same pinout. The 74 LS164 again is a shift register, so it will just shift bit by bit an 8-bit values out to this register. Okay, just like this will. So the difference is this one, the bits can actually be disconnected until you want to actually apply it. And then finally, the Johnson counter. And what the Johnson counter is often called a ring counter. Basically, it has 1 bit and all zeros. And we'll talk about the Johnson counter a little bit because we're actually going to use that one here. Okay, now let's look at some examples of this. Our first example is an 8x8 LED matrix. 8x8 LED matrix. And In this case, we're going to use the MAX 2719 driver. Okay, MAX 2719 driver is what we're going to use. So that's this chip. Again, you communicate to it serially. So it's designed specifically for LED driving. That's one of the things. You can use it either to drive arrays of LEDs or else displays with 8-segment or 8 LED displays, like an 8-segment LED display. It has an SPI interface, so you communicate to it through SPI. In this case, you're able to string. You can use one of these to string a number of 8x8 arrays together, so you can have these little blocks side by side and create a scrolling marquee that goes across many arrays. And an important part about this, the MAX 7219, is that there's library support for it. So it's like, that's sweet. That makes a big difference in terms of being able to just get right in and use it. Boom. So there are actually two libraries that are important that can be used. There's the graphics library from Adafruit that they've made available to us. Thank you, Adafruit people. And then there's the general, just a general control library, Max72XX panel library that we can use. Incidentally, you can get these libraries on GitHub. So here are the references for those libraries. You can just download them and install them. They have a README document that tells you how to install them. You just install them into your Arduino installation, and then it can access them and all that good stuff. So if you get to this page, you want to download it. You need to actually look for this little. It's actually here. It's really big, but on the page, it's going to be off in the right, down a bit. And that's where you actually download it. Otherwise, what you'll see is you'll see all the files and folders that go with this, and you think, okay, I need to click on that, but you don't click on that, okay, to download it all. You need to go over to this button and download it, okay? That's a gotcha, okay, because that definitely threw me for a loop for a while. So this is how we get the libraries. So I'm not going to talk so much about programming this, because there are some really nice sample programs, and I'm going to demonstrate some of those sample programs here in just a bit. But so they've already gone to the trouble of writing the essential driver documents that are needed to do this. Now I want to extend special thanks to one of my students, Robert Brink, who actually introduced this particular shield to me, this 8x8 array. In my class that I teach of this, he showed up the first day of class and brought in his Arduino with his 8x8 array already programmed, and it scrolled his name across. So I knew exactly who he was. So I was just impressed that, first day of class and he's already figured out this very complicated thing. So the other thing that's really nice about these 8x8 arrays is, first of all, you can string together multiples of them. Second of all, they're cheap. So these are a couple of listings that I just found on eBay. So if you're willing to wait for them, to get them from China or Hong Kong, for example, you can get them for really cheap. So this one's like $4 for 2. Wow. Or this one's $2.29 for 1. This one has free shipping. This one has $1 shipping. So they're really, really inexpensive as far as something to play around with. It's definitely a nice little toy to play around with. So let's get in and let's do a demonstration of this. Okay, well, here we are with our little project here. And one of the things I also wanted to show you in this little video is I found these little guys, and these guys are so nice. They're so nice. They're these little connectors. It's actually a ribbon cable that have these little connectors on it. So these little points, they push right into your Arduino, and they're so handy because they go right in, and they if I have 2 of them, they go right in together. So they'll go in right into adjacent holes. and their connector doesn't interfere with that. So I have these nice little connectors, and they actually, so if you just buy those other ones with the round little ends, they don't go together like this. Okay, the little connector end thingy is too fat, so you can't put them into adjacent holes. So that's one of the things that's nice about these guys, is that they actually go into adjacent holes, and they're also as a ribbon cable. So in other words, they come together, and you can pull them apart if you want to separate them, if just to use specific ones. But they're cheap, and they're really, these are amazing. I'm glad I found these. Anyway, I want you to introduce you to these. You can get them on eBay or other places, but they're really, really handy. Go look for them. Okay, so here's our little circuit over here, and we are wanting to program this now. So I have up here one of the examples from Adafruit of their graphic library, graphic GFX, graphic effects. So notice it uses these two. It also uses the SPI library, because again, it's communicating by SPI. In this case, you need to attach your little guy up to the proper connections, and so I'm using this breadboard to kind of hold everything together. Okay, I'm using it that way, and so to make the proper connections, you have +5 and ground over here. Then you also have the 3 pins that are needed. In this case, it's 8, 10, 11, and 13 that are needed. And so that's associated here. Pin 10 is the chip select for SPI. Then you hook it up into MOSI, which is MOSI, which is pin 11, and then clock goes into pin 13. So that's how I know how to connect this guy up to this. Okay, so it's fairly straightforward. So now that I've got it connected, I can go ahead and load this in. And basically, it just has this little pattern where it just kind of buzzes around like a mad fly. So that's the name of this program, Mad Fly. Fun little deal. Now I'm going to use another program, but before I do that, in between programs, I go ahead and do this bare minimum program. I go ahead and run it and upload it just to kind of clear everything away, and so I just find that that's helpful. Okay, so now this one is called Snake, and this is kind of a little funky little thing, so let me go ahead and load it in just for fun. These are fun little programs that they threw in there. It's cool to modify it. So you can see it's like a little snake that's crawling around the screen, and it just kind of goes in random directions. So it's kind of fun that way. It just kind of randomly goes around, and it looks like it stops sometimes, but actually it's not stopping. It's actually doubling back on itself. So that's a fun little one. Snake. There. Now after clearing my display again, I've gone ahead and loaded up this other program. This one is called Spin, and so it does something a little funky. It basically plots a line on the shield, and then it rotates that line, and the speed gets a little faster and faster. So it's as fast as possible, and then it slows down again. Slows way down, and then it starts speeding up again and keeps going through that. I was kind of hoping it would go backwards, but no, that's all right. I mean, it does what it does. So it's pretty cool what it does. So in order to do this, again, these lights are flashing. Okay, so those lines, they look like they're in line, but it's actually one light at a time being lit. They're not all out on at the same time. All those dots in the line are not all on at the same time. So again, your eye sees it as if they're all on at the same time, but they're actually not. Pretty funky. This last program I want to show you is again the last demo program that comes with this library, and that is the ticker, like a ticker tape or like a marquee display. And so here I'm going to have it display hands-on Arduino, since that's where I've changed this line in order to do that. So, and here they called it tape, as if it were a ticker tape, even though it has nothing to do with tape. And so you see hands-on Arduino. There we have it, hands-on Arduino. It is in motion. We have it in motion. Cool. Our next example is another set of LEDs. This is a handmade circuit. So another one of my students came into class, the second day of class, and brought in his little circuit that he had made together. And so this is example 2. We're going to be using the CD4017B driver. Again, we're doing this using multiplexing. And so the way this one works is that you have your array. In this case, it's a 10 by 10 array. So instead of you having 64 LEDs, this has 100 LEDs. And so again, in this case, if you set this one high on this side and high on this side, that lights this LED. Okay, so high basically closes the switch, so you have a set of transistors on the sides and resistors that work together to, for this example, to light the LEDs. So in this case, this would require 20 pins of control. The pins are controlled by 2 CD4017B chips, 1 for each of the sides. So each of these chips has 10 outputs. Okay, so one controls the row, the other controls the column. So when the shown bits are high, so when this bit is high and this bit is high, then that LED gets lit, and so forth. We can go down right down the line in terms of, whichever row and column are high will be lit. So the chip, the 4017B, is what's called a Johnson counter or a ring counter. And basically this has all its outputs equal to 0 except 1. It has 10 outputs, so all of them are equal to 0 except 1. And each time the clock pulses, the 1 moves to the right. So forth, anyway. And when it gets all the way to the right, then it starts over on the left. Okay, so forth. Okay. I'm not very good at demonstrating that. So basically, this requires addressing each LED, each scan. The LED, again, is lit to the appropriate level. So we can actually change this by the amount of time we leave the LED on, when it's on. So my student came up with 2 different programs, and so I'm going to go ahead and show you both of these programs in the same way that I had programs for the other LED array. The first one is called LEDS1.ino. This program displays the logo for my student. The second one displays the LEDs where basically it's a pattern where the lead LED seems to bounce off the sides of the display and the LEDs trail behind, kind of like a comet, and they gradually fade as time goes on. So I want to extend special thanks to Christopher Clem for letting me borrow his circuit and demonstrate it. So you can find out more information about this at his website, nido3000.com, and so I encourage you to check that out. Let's take a look at the circuit. So this is actually just the beginning of the code that he wrote. I'm not going to distribute this. He asked not for distribution, so I'm not distributing it. But you can kind of see how it starts off. It's not enough to give you the meat of it or anything. So let me go ahead and load it into our Arduino, and here we have scrolling LEDs. So notice that these are a little bit bigger letters, a little beefier looking. He has a little smiley face at the end there. So this is the first one, LEDS1, and that's actually a name I gave it. That wasn't his name for it, but that's the name I gave it. And so for our last demonstration, we have this. This is the second program. I called it LEDS2. He called it something different. Again, not for distribution, so I don't let you see the whole thing. Just you can. Well, here it goes. Just you get all that. Okay. So I'm going to go ahead and run this, and there you go. So you see the little lights are just kind of bouncing off the walls, and it's following a little pattern. So when it goes certain angles, it goes really fast. Other angles, it goes kind of slow. So, but it's pretty cool how he not only has it bouncing off the walls, following its particular pattern, but how the lights get bright and then they dim gradually over time. So it's pretty sweet what you can do if you put your mind to it. This is just a project one of my students came up with. You can do some exciting things too, and I'd love to hear any stories that you have or any example circuits that you have. Maybe if it's really cool and I can be a part, get connected up with you. Perhaps your circuit could be on another edition of Hands-on Arduino. Thanks for watching.